Dear students, I am Moiz Shamuddin, Assistant Professor of Mathematics at MBSR Engineering College, Hyderabad. Today, in this session, we will see now limit comparison test. Limit comparison test. What this test says, let's see the statement first. If sigma un and sigma vn are two series of positive terms, we are limited to series of positive terms, and limit of the ratio of that un and vn as n tends to infinity, it is equal to some real number that is not equal to 0, then sigma un and sigma vn both converge or diverge together. It just says that both will be convergent or both will be divergent. If we know about one among them, then we can declare about the other one. The same nature will be there for the other one. Let us quickly solve a problem on this one. It's actually a revision for the limit comparison test. We have already seen in class. Test the convergence of the series sigma n square plus 1 divided by n to the power of 4 plus 4n cube plus 2, suppose n is equal to 1 to infinity. Here the numerator and denominator are polynomials in n, then the best choice is limit comparison test. Let us see now the working method. Given series is this as it is, I am copying n square plus 1 divided by n to the power of 4 plus 4n cube plus 2. This I call as sigma un. Say means I am taking this complete as un. Implies un is going to become as n square plus 1 divided by n to the power of 4 plus 4n cube plus 2. Now the basic fundamental behind this method is, from this un we will try to prepare a vn for which we know the nature. Now what we do is, highest power from the numerator I am taking common, so it becomes like this, and in the denominator again I take the highest power common. Okay, I want to rub this one. I take n to the power of 4 common, highest power, so it will be 1 plus 4 by n plus 2 by n to the power of 4. After cancelling these powers of n, I get the net result as 1 by n square into 1 plus 1 by n square divided by 1 plus 4 by n plus 2 by n to the power of 4. Now what I do is, this outside net result of power of n, whatever I got it, this particular thing, I take it as vn. So I change the color now. I say that let vn is equal to 1 by n square. This complete is un, and this vn is 1 by n square. So we have prepared Vn actually from our given Un. Un will be given I mean, a series is given, we have taken that un and we have tried to prepare Vn from that un. Now, limit n tends to infinity, un by Vn is nothing but equal to limit n tends to infinity. This complete un, this is un. So un by Vn will be this by this. So this complete 1 by n square gets cancelled. So I will be left over with only 1 plus 1 by n square divided by 1 plus 4 by n plus 2 by n to the power of 4. This complete, we are finding the limit as n tends to infinity. And you are all clear that. Okay, I will cancel this. I'll erase this one so that you can take the screenshot of this one. Now that is equal to, if you separate the limit, then you know all that limit can be separated for the numerator and the denominator, and term wise separation is possible. So using that concept, term wise limit of the constant is that constant. So 1 plus 0 divided by 1 plus 4 times of 1 by n, that is 4 times of 0, that is 0, plus 0, that is equal to 1. This value is important in the sense that it should not be equal to 0. If it is 1 or less than 1, greater than 1, there is no issue with this one, negative, positive, rational, irrational, complex, whatever it is. The point is that it should not be equal to 0. It should be a real number. It should be a real number, any real number not equal to 0. So once it is not equal to 0, then limit comparison test says that, therefore limit comparison test says that sigma un and sigma vn are of same nature, in the sense that both will be convergent or both will be divergent. Now I change the color because the concept is changing. But sigma vn is sigma 1 by n square. You can see here sigma vn, that is vn is 1 by n square. So sigma vn is sigma 1 by n square, is convergent. How it's convergent? Because sigma 1 by n square is looking like sigma 1 by n power p. This p is 2 and p is greater than 1 condition satisfied. For greater than 1 it is convergent, for less than or equal to 1 it is divergent. And hence we have come to the conclusion that sigma vn is convergent. Okay. So sigma vn is convergent. Therefore, once it is decided that sigma vn is convergent, by limit comparison test they should be of the same nature, and hence we conclude, hence sigma un is also convergent. Therefore given series is convergent. Series is convergent. I hope you understood. You have several situations where you can use limit comparison tests. The basic fundamental point, okay, fundamental point is that when you have sigma and n is the base and power is a constant, then okay, plus n some constant plus n some constant, okay, constant by n to the power of some constant, If this is the situation, then the best choice is limit comparison test. In some situations where Vn we will be preparing by ourselves, let's do one more problem. Test the convergence of the series sigma sine of, okay, sine, trigonometric function sine of 1 by n is equal to 1 to infinity. Solution. Given series is sigma n equal to 1 to infinity sine of 1 by n is equal to sigma un, say, implies un is sine of 1 by n. But we know from intermediate that limit theta tends to 0, sine of theta by theta, that is equal to 1. Now, in the place of theta, we have 1 by n. And as n tends to infinity, 1 by n tends to 0. Therefore, this theta, if I write it as 1 by n, sorry, okay, fine, 1 by n, let it be. I'll rub this one completely. Using this concept, we proceed. So let us take Vn let Vn is equal to 1 by n. Therefore, limit as n tends to infinity un by Vn, this complete is limit n tends to infinity sine of 1 by n divided by 1 by n. And this is same like limit 1 by n tends to 0 sine of 1 by n divided by 1 by n, and this is going to become 1, and this is not equal to 0. This limit should not be 0, that is our requirement. Since limit theta tends to 0, sine theta by theta, that's equal to 1. So, therefore, by limit comparison test, sigma un and sigma vn both are of same nature, but sigma vn is equal to sigma 1 by n is divergent because of the p test. P value is 1 here, 1 by n power 1. So p value is 1 and it is divergent. Therefore, by limit comparison test, once it is decided for sigma vn, we can also declare about sigma un. Therefore, sigma un is also divergent. Hence, given series is divergent. I hope you understood. Thank you.